Hi, her. Warte mal. Not how it's called?
Geerts.
Geert. Exactly.
Yes.
Geert.
Hey,
Geert.
Adam. Good to speak to you again. Looking forward to this conversation. It was a fun one last time.
Yeah, this one is maybe even better because the most important question, of course, is what was your first synthesizer?
Ooh, that's a really nice one. My first synthesizer was a successor to the Yamaha DX7. And I always get mixed up with the model number. It's the SY100 or the YS100 or something like that. But it's basically, I got started with that and MIDI and the Amiga as my first way of making music. And I was creating all these sequences on the Amiga and running all my MIDI cables through my bedroom at home. And recording it all on cassette.
Okay.
I never really been a synth player because I'm a guitar player. But what I was doing was dialing in sounds and then like sequencing them with a sequencer and learning how synthesis works.
Okay.
Which I didn't understand anything back in the day, but now it's a little bit better.
So you were a huge Jean-Michel Jarre fan, for instance?
I've always been a huge Jean-Michel Jarre fan. Yeah. I mean, all this time, like he's continued making beautiful stuff.
But he also constructed his own synthesizers, right? So
I know someone who used to work with him. Yeah.
Yep. And so the question has been, what was your first Moog? I think is pronounced correctly, or Moog? How
my first Moog? Yeah. It's not next to me right here. When I moved from Belgium to the US, it's one of my like few items that I shipped over. It is actually the Slim Fatty. Like Moog has like known for the Little Fatty, but the Slim Fatty is the same sort of bass centric monophonic synthesizer, but without the keyboard, because I was interested in playing it with other ways and not specifically piano keys, and I could just have this module sit on my desk and hook it up to various weird contraptions and experiment with it.
Can you run it for 10 seconds, or is it?
It's not hooked up. I mean, I could hook it up, but it will take me like half an hour to get the sound throughout. Okay. I mean, I can make it sound now, but to have it come to you, I would have to like route it through a bunch of things.
Okay, it'll be interesting. And you said the Moog was the company who invented synthesizers, right?
But Bob Moog was one of the innovators that started synthesis and popularized it by attaching a piano keyboard to a synthesizer, so that people that were not necessarily interested in programming it or what is called patching it could just step up to it and play on the keyboard. So, oh yeah, this already makes sense to me, and then turned it into like that one of the synthesizers that became one of the most iconic synthesizers in the world, like the Mini Moog Model D, which is like an evolution of what Bob was researching of how can you package what is absolutely necessary in like this analog synthesis in a portable package back in the day, which is big for nowadays standards, but it was really small for the 70s. And the Mini Moog is still, like Model D, is still being sought after, and Moog has put it back in production a while ago, and people are still buying it because it's got this design where it's simple enough for someone to be able to start understanding synthesis and complex enough for the sounds to be diverse enough, so you can get to so many different places with it. And so it's very rewarding. You don't have to put in that much effort to understand how it works, and then you can basically explore a whole world of synthesis.
When Moog was invented, or when the first was created? This is interesting.
I'm really bad with dates, but like in the 60s.
60s, okay.
So, yeah.
So
somewhere, yeah, somewhere around there.
And what bands played or used Moog in the so?
Which bands did not use Moog?
Okay.
I mean, it's like Thriller, like all the big songs, like the whole disco era.
Oh, okay.
Like everything that has like a really strong synthesizer bass line or a synthesizer melody. Most of the hits have a Moog synthesizer in there from that period of time.
What about Kraftwerk? You know Kraftwerk?
Kraftwerk used a Model D. Yeah.
Oh, okay, interesting. Yep. Okay, cool. Yep. So I took a look at the website, and it looks really interesting, beautiful. This is an interesting design, of Moog. So and also the hardware looks interesting. Is old and new at the same time. So it's beautiful.
Yeah, we really try very hard to respect our legacy. Like to respect the designs that have stood the test of time, but then also to innovate. So how it's a wide chasm to span so many decades, but we try to push forward every single time we release a new product.
I think now it's easier, right? Because now people really like the old stuff, so the old look. I think 10 years ago was maybe a little bit harder because everyone wanted to have like the super modern look and feel. And right now, I think people appreciate knobs, real knobs.
Yeah, for sure.
But 10 years ago is not that, or 5 years ago even, everything has to be touch and
I think like you were right, like around 10 years ago, and it has remained since then. Like people have started to appreciate, and also the analog sound, like the whole like section of our product catalog is only analog synthesizers where there is nothing digital in the sound path. And it has that warmth and organic nature to it, which feels good if you're like surrounded by digital stuff all day, every day.
So, last time you wore a hoodie, and there was a logo on it. So, was it like I wanted to ask you the last time, but there was no time. Was it like heavy metal band or something? It looked like
It must have been Heilung, because I'm a really big fan of Heilung, and my wife is too. It's a Scandinavian band, and they go back to the beginning of music, to the first written recordings of lyrics and notes and harmonies, and then interpret them how they would be nowadays with instruments that are now available. And then basically their live shows are rituals that are also informed by historical facts, like how people, the Vikings around those days, would be performing or having these rituals around the music. And we really like going to these shows. They're always
Heilung is the name of Heilung. Yeah. Okay, so a German name even almost.
Yeah. And there's a whole bunch of German passages in their songs. Also, they have like also a mixture of music and spoken word, and sometimes like there's a whole narrated passage together with like rhythmical elements, and many of them are actually in German.
Okay, so now what I also did, I checked out the Builder or BLD and Rife.
Yeah.
And took a look at the source code because I wanted to see, what you actually did. Okay. And what I was surprised is the amount of Javadoc you actually spend time to write. And everything is well documented. And you spend huge amount of time working on it, right? Or you are a fast typer?
No, this is a lot of work. Yeah.
Yep. But this was actually not your actual job, right? You did that aside just for fun, more or less.
Yeah, but a lot of Rife has evolved over 20 years of time.
But you migrated. What I saw was Rife 2 already. So, okay.
Yeah, I firmly believe in like when you. So obviously you've got unit testing, you've got functional testing, but I feel once you document an API, you actually it's like you have to explain something to someone. And it gives you a whole other point of view on what you've just created. Like, if it's hard to explain, something's wrong. So that's what I like about writing Java docs, because if they don't make sense, then maybe like you have to take another look at like how the API is constructed.
Absolutely. So for me, less is Java doc and more like I call it system tests, like black box tests. So if you test from outside, you are also forced to use your own API. And think what you did. And the difference is because I thought, why I'm writing a much less Java doc than you did. But the difference is you created a new framework.
Right.
And what I'm doing usually, right, I'm building more or less boring applications on top of a framework.
Mm-hmm.
So if this is I always work with the same structure. I actually stolen it boundary control entity. It
Mm-hmm.
was the maybe the oldest pattern is before
Okay.
UML. So, and the idea is that you structure your project with packages with business names. So
Yeah.
and every package has the same structure, boundary control entity.
Yeah,
And
I've seen that. There's like another framework that was using that, a Java framework. What's it called? I don't remember the name.
It was everywhere. This was this
Yeah.
agile modeling and robustness
Right.
patterns, and I even had a chat with the creator of the entire thing. It was invented by Ericsson
Mm-hmm.
in the 70s or 80s, and there's also known icons where we can just use everywhere.
Nice.
And so I have always the same structure. So what happens is everything is self-descriptive. So there is no way. I think it's just hard to write reasonable Java doc, because if you see the boundary, okay, custom is created or customer is found. So there is not a lot.
Right.
I only document stuff if something unusual happens. But in your case, I thought, okay, this is different, because they were your thoughts and you have somehow justify why you did something, because it's a very new. Rife is not like anything else, not
Right.
comparable. So and Builder is the same, right? So
Yep. And like it's sort of, for me, the first stage of writing the user guide. If I don't write the Java docs, then it's going to be really hard to write the user guide, because then when I'm writing the user guide, then I'm hitting all of these questions like, how do I explain this? Does this make sense? Is it short enough? Yeah.
And so what interests me, so there was a Rife 1. And then you decided to write Rife 2. And I took a look at the code. You're using modern stuff. So you're using text blocks, I saw. So it is actually, So how was the migration?
Like all of it. Yeah.
Was it hard? Or what was, the hardest thing you had to face? Because it is actually, I also migrated some projects. And for me, it was more or less fun. And the reason was because what I migrated usually is from ancient J2E stuff to modern microprofile in Jakarta. And this was mostly fun because Jakarta microprofile became more powerful. So I just deleted my own proprietary stuff and replaced it with standards. This was the most migration projects.
Yes.
But in your case, it was your own framework, which was based on JDK 1.2, I suppose.
Oh, even before that, I started in JDK 1.1 and then started pulling in a few things later, but I still had to preserve like backwards compatibility for most things.
Okay.
When I started working on that, it was sort of several things happened. Like I hadn't written Java in a while because I was like writing macOS and iOS apps and focusing on synthesizer DSP and like optimizing C and C++ code, working in Xcode or working just like in the terminal and the VI. First thing, I was like, oh my God, this is so comfortable. And I remembered that Java and IntelliJ was so comfortable, but there's one thing about remembering it and then experiencing it again. It's like, oh my God, like my IDE understands me again. Like I can just stay in the flow and code. And anytime I want to use any of the smart completions, they're actually helpful. It's not like, here are all the tags that match on text, and then like 99% of them will not work, but maybe 1% will work. Like it is actually typed and it's actually usable, which is such a productivity improvement. So that was, obviously everyone knows that in Java, but that was like me basically coming back home and saying like, oof, it's nice and cozy at home. Like I had forgotten how good it was.
Yeah, interesting, because I had a chat with Swift and Xcode developers, and they were really excited about the IDEs, and I was like, this is nice. And I also tried, to build something in Swift and
no
SwiftUI.
comparison.
Yeah, and it was I managed to do something, but it was like I constantly had the feeling that I do something wrong, because there was it was hard. It was like it worked. But I thought maybe I used to know a wrong view, because lots of views I had no idea what they are actually doing. So it works, but
views and the view modifiers in SwiftUI are just this giant grab bag of here's 300 view modifiers that maybe work on the view that you're using. And like, I have no idea which view modifier actually works. And then this is like my pet peeve with SwiftUI. I've just been doing 4 months of SwiftUI, so I'm like right in the middle of it. It's like my pet peeve is now so not only don't you know which view modifier works on which view class or struct, the order is also important. So if you mess up the order, then the behavior is not going to be the same. But it's not the case for all of them. It's just the case for some of them. So it's like you have to basically have this giant collection of examples that, okay, if I want to do this, let me look at that snippet of code, and I'm just going to copy that little part. And if I want to do that, I'm going to copy from there. And that's the only way. Because even if you go through the source code doesn't have a clear collection of what applies to which, basically their headers is not source code, but they're all written in extensions. So it's like, I don't know which class this actually will work with. Swift, it's miles away from what you can get in terms of productivity and
this
comfort.
was also my impression. So good that you are confirming that, because it's,
Still, Swift is a cool language. Like I actually like the syntax.
Yeah.
It's pretty concise but readable. Like usually it's difficult to find that tipping point when making it really concise, and then you're like, I can't remember what I just wrote. Like I like the balance that Swift has struck there. But in terms of IDE support, it just doesn't justify it. So yes, and then migrating the code was so surprisingly easy for several reasons. First of all, again, IntelliJ IDE, they have all these intelligent migration tools where you're like, hey, I'm detecting this thing that you did. You can do it better this way. And it's like, okay, automatically convert. And it's like, yep, it's automatically converted. And now I'll tweak it a little bit. And it's like, okay, how can I make this better? So like the hard part is already done for you. And then like being able to really lean into lambdas. I just love lambdas. And being able to have them properly typed, and being able to actually create sort of micro DSLs with them. I love doing that. And it used to be that you had, like, I already went that route with Rife 1, where you have these anonymous classes, and you could sort of, like when you have the anonymous inner classes that you instantiate locally, you could sort of get there, but it was like a lot of boilerplate code. But being able to do that just with the lambdas and the function classes, it's so awesome to work with. I loved it. It was really exciting to actually do this.
What's really surprising in Java as well is how good Java is for command line tooling.
Yep.
And maybe, I don't know whether you know, but what you can do in Java, you can do Java without Java C and invoke the main method, right? You can say Java and app.java, and it compiles behind the scenes and runs the Java code. So this is surprising. That's the first surprise.
Yeah, that's how we started with build, actually. That's like
of course. You are the builder, so you have to know it. So, but the second thing is, if you would like to parse something in Java, right? So it is amazing. You can say files, read string, you have the string, so it's one-liner. Then you can say string.lines, and you have the lines of the string.
Yep.
And then it's already a stream, so you can map it to uppercase and filter, and you're done. I mean, this is like crazy. So I would say, and don't forget Z shell or Bash or whatever. You can have a one-liner, and you are done.
Yep.
And I do it all the time, so more and more. And I have I replaced some shell scripts, because what you can do is actually you can put it to the path. In the path variable, it's just there. You can just execute the thing. And for me, it's easier. You can debug the actual thing. A Z shell is really hard to debug, if even possible.
Exactly.
I don't know. Yeah.
So what you're saying here is exactly why I started build, because I was messing around with make for forever, and then CMake, which is an even more frustrating experience, but it's somehow like it's popular. And then there's been scones, and then there's been Maven, which is, I liked Ant, but it was XML. And then it was like, when I started again with Java, it's like, okay, guess I'll jump on the Gradle bandwagon, because that's what all the cool kids are doing. It was like, how is it possible to be so hard, to be so difficult? I like what you said. The main thing for me was like, why can't they just debug my build script? Like, I'm already writing in Java. Why would I want to write it in something else? Because I have access to all of the Java capabilities if I would be able to write my build script in this. And so that's why I started build. I was like, you can just do a file.java and execute it, and it does what I wanted. And it's like, okay, maybe I'll just write my build steps in a Java file and just compile the things. And okay, this is cool. And it's like, how can I make this into something reusable that like my people in my team can use? And how can I make it so that we can actually do dependency management and all of that stuff? And then I went away from that .java approach for the simple reason that I want you to be able to modularize your build script so that you could create classes that abstract certain pieces of functionality, but also pull in your own code if you wanted to. And that is not what the .java approach is set up for. It's supposed to be self-contained. And so what I then did, which is what Gradle also does, like you have this this bootstrapper that sort of sets up the class path and the environment and all of the things, right? And from there onwards, it is full on Java, like calling the Java compiler from inside Java to recompile if there's changes detected, and then you just write your build code in a Java file, and it's so convenient. Like there's no context switching. You have, like you said, access to all of the Java power. Like, oh, I want to do a little bit of text manipulation, and I want to do this thing like where I replace this by that, and then I like, and any of the tools you already know, the APIs you already know in Java are just there, and your IDE helps you. You can just autocomplete, you can debug, you can set breakpoints, you can set conditional breakpoints in your build script. This is really cool.
So there's a completely different philosophy. So I didn't use Gradle at all. And because in my world, boring business applications, Maven is just great. So because I have almost no dependencies, actually no dependencies. If I'm using Quarkus, this is like, my server. Everything is, we have just the Quarkus dependencies. If I use back then with application servers, there were no dependencies at all, just the Java E API. So all my build scripts were identical, basically, were like 50 lines of code, and I just did Maven package and I was done. So I never got the idea why someone would like to use Gradle. And I know why, because of Android, right? Because of Android, this Gradle was able to have all, the different tests for the different devices, and Maven would be not suitable. So Gradle was a programming tool, and Maven was just a declarative build tool, which was perfect for me. But with Builder, what's interesting, what you described now, it didn't occur to me. It goes one step further. What we could even do with Builder, we can make Builder part of the application. So actually, I don't know whether it was meant this way, but the idea I got right now, I could actually use Builder as, the entry point, then write and ship Builder with my app as an app.
That's what we do. That's how we deploy our apps now.
Okay. Okay. So I thought this is something revolutionary, I will tell you. But if you are doing this, okay, this is almost like I spend the time in the cloud with infrastructure as code, but this is like, build as code or something like this, right? This is like,
and it's so convenient. And there's like one key piece like that a lot of people started talking to me about when I did this, like, what about your dependencies? Like, what about pulling in all of your jar files? And I was like, how often does that change? Like, how often do you actually change dependencies? Like, there's so much risk involved when you change versions that is a conscious act. Like I hope that you're not building applications where you automatically upgrade all your dependency versions, because then like you're always chasing problems. So this is a very infrequent operation, like pulling down dependencies if you have them. So in build, it is actually structured that way, where it can pull out Maven structured dependencies for you if you want to. And there's a command to do that. You can automate it if you want to. And in that case, it is only when you make changes. It's only when there is a change to your dependency graph that it will actually do that work. So in the majority of the time, it's just a no-op. Like the dependencies are just there, stored in your class path, with your project, available to the IDE, available to any other tool that would want to use it. And there's no need to have this like separate repository of the whole internet that you cache on your computer, like what happens with Gradle and sometimes with Maven. It's only just your set of dependencies. And then if you decide to upgrade to different versions, you can use build to assist you with that, or you can do it manually if you want. And then build can, if you want to, purge out old versions that are not part of your dependency tree anymore. But it's always something that you are aware of. It's not every time you make your project, it's going to do all that dependency stuff, and you need to be connected to the internet. And if you're not, then you need to like do something special. And with Gradle, like you have all these daemons that are running to speed it up, but then some daemons might be on an old version and you have to shut them down. And so yeah, all of that is just very straightforward and empirical. Like, okay, well, I'm using the jars that are with my project. If I want to change, I'll change them and use the tool to easily fetch them and figure out the relationships, but that's it.
Yeah. For most of the project, I don't have any dependencies. Java 21, sometimes I need them. For instance, right? So if I'm running CLI with AWS SDK, so I need AWS SDK, so there's one single dependency and anything else is Java 21.
Right.
So another question. So I checked out the builder and I wanted to build the builder. Is it necessary to build that? Because all you're supplying is the builder wrapper, I think, or BLD wrapper, right?
Yeah. So you don't have to build...
Chicken and egg problem. So how to build a builder?
It actually builds itself, but it has to have the first wrapper, which like it's a very small wrapper around getting everything set up. It's basically class path stuff and making sure that like the core jar is being downloaded. That was my problem when I started it.
This is what I thought. As I look at that, I tried to build it. I got some errors, but I started the BLD script.
Yeah.
I just tried to make, the listeners curious, so they will try by themselves. So the BLD script, and it pulled the dependencies, but then failed because something couldn't be found. But I think you tested always with IntelliJ, and I tested hardcore terminal. So no,
I always test with the terminal, actually. Okay. And Eric, who's going to be on your podcast in a couple of weeks, right? Eric Touva, he usually uses IntelliJ. I use it most of the time for coding, but I like using build on the command line. So it'd be interesting to see what your problem was. Like maybe we can look at it after the podcast.
Yeah, sure. So I just did it before the podcast. So if I start BLD, then
how did you install it? How did you install build?
Git clone. BLD, just clone it, and I just run the BLD. Nothing. I did nothing. I was curious what happens. But there is nowhere is explained what to do actually, right? So there is no.
Well, there's a whole manual though.
Yeah, but it's a full documentation. So this is a quick start, and it's okay if it's a quick start, how to build it, right? So I didn't look at the full documentation because you said on the manual. This is the quick start, so okay, then let's start quick. And the manual, I didn't, look at the full manual. I was just curious what happens. But I will try it. So to give it a shot. So in both cases, my feedback to Rife 2 and BLD. So the source code looks great, and everything is absolutely what I really like. Promotion of no dependencies. I think you stolen it from me because I this was on my marketing line for years, and now you have it, right? But But there should be a simple, quick starter. We start with, in order to build Rife, do this, and in order to build builder, do that.
So it's not necessary to build in order to use it as a build tool. I don't know if you've seen the wiki of build itself on GitHub.
Not yet, but just my feedback is you have on the first what I do in an open source project. I expect in the first in the first paragraph to see, okay, in order to use it, do this. So this is my expectation. And in both cases, it looks like a quick starter, but it's just an explanation of the philosophy. Yeah. And then you have to be more explicit. Click on the link to do something. This is my feedback.
That's really good feedback. Like it's definitely written for people that use it and not for contributors, not for people that start from the source code. So thanks.
And I also took a look at the Rife too. And what's also was not unexpected, because with your conversation with you the last time, you say it's just a war, but it actually ships with Jetty, I think. So you can just run it as a full stack, right? So because
yes, you can. Yep.
yeah, which is cool. Because I thought, I have to build it as a war, and then I thought, okay, how to get a war? Because I will need a builder. But it's okay, I can also use a Jetty, and then you have a main method, so you can actually boot Rife with a main method, which will start Jetty and then Rife, which is
or Tomcat. Like that's one of the things that I'm really passionate about. I hate myself not understanding how something starts up. I want to be able to reason about where the entry point is, and then be able to have control over everything that happens up until like my application is running. And that is why I think it's really important to make that main method explicit and to design the API in such a way that there's almost no boilerplate code from there onwards, but that you understand every single step to get your application up and running.
Do you know JWeb Server?
I've heard of it, yeah.
This was it was initiated by Sun Microsystems, and it is now part of the JDK. It is not meant to be in production, but it supports routes. It supports this is a basic HTTP server. So I just wondered whether it is possible to run Rife on top of JWeb Server, because then you have no dependencies. This would be pretty cool. So
great idea.
Yeah, you could actually. Maybe it is not powerful enough, but you could actually start Rife, without Jetty. This is like immediately, 2 megs less or something like that.
Yeah, definitely look into that. It's a great idea. Thank you.
JWeb Server. Okay. So the last time we stopped also the discussion with about templates. And what I understood is your idea about templates is that this is just a how to call it, a document with holes, right? This is how you see templates.
A document with holes and with reusable parts.
Yes. So what it means is that there is no control logic, right? No for, no if, nothing. Okay,
nothing
so
at all.
Purist. Okay. Okay. So what you will like is string templates, right?
Yes. Yep.
Okay.
I think that's really cool. Yeah, I like string templates. I also like.
But they are not available yet, right? As preview.
Not yet, but there is. The guy who wrote Antler. He also has a template engine, which I think is called String Template. Also, like it's something with string in there. It's pretty cool too.
But they become part of Java 22, 23 or whatever.
Yep.
And they will be really powerful, and you will like them, right? This is what I'm looking for.
I have not delved deeper than the surface, and it looked cool.
Yeah.
So yes, I'm excited to dig into that for sure.
What's interesting with the string templates is there will be a string template processor, like in JavaScript, and the holes can be typed, so you can create your own, almost like DSLs, and they have already examples how to create, or they have examples. The idea would be to have SQL queries, which are typed. So I think it will also fit perfectly. So what it actually means, Rife or with Builder could become, this no dependencies full stack on Java 23, right?
Yep. It's a good point. I had a plan to continue looking into the string templates for sure. One of the things I wasn't sure they had was the actual reusable blocks. I remember seeing the holes, but not the blocks that you can get back out of your template and manipulate outside of.
Okay.
In your
then
code.
I still don't know. So, but I think this was also what I wanted to mention the last time, but we have absolutely no time. Okay. So we covered a little bit the builder. So what is the Hello World builder to the listeners? So I just explained what was my experience, but let's say someone would like, to create a Java application with a main method, Hello World inside, and use Builder to build the entire stack. So
these are the steps. Like you typically install it as a standalone tool, as a tool that is like you have Make or like you have Maven or Gradle. Like you have your tool in your path, right?
How to install the thing? So
there's several ways. Either you can download the jar file from GitHub and do Java jar, and it's an executable jar. You can just launch it that way. Right?
This is from releases, right? You go to Builder, release the jar, and then you can put it to the path and launch it with Java-jar.
Yep. You can also use SDKman to install it. You can use Homebrew on macOS to install it. You can even call it through JBang if you don't want to download anything. You can just put the JBang command line in there. And so once you have the main tool, it's basically the project creation tool. It's sort of like you're outside of your project, and you can create projects with different templates. You type in build or whatever, Java jar, the build jar, and then create, and it's going to prompt you with whatever is necessary, like the package name, the main class, like all of that stuff. And then based on the template that you use, like it could either be set up for a library or for a standalone application or for a Rife 2 project if you're building with Rife 2. It will create a bunch of starting points, which could be a main class with a main method. From there onwards, you go into the folder that is created for your project, and you have build is present again in your local directory, but it is it's the inside version of build. It's a build that actually uses your project and that uses your build class with the Java code that actually has the build logic from your project. And from there, you can then do build, compile, run, and your application runs.
What you should also put exactly this, not in the GitHub, rather in the builder page, that an homebrew, for instance, a homebrew reference SDK and JBank, because it is also not. I couldn't find it at the first glance. I immediately said, okay, it's not there. Then I switched to GitHub. So cool. Then I will clone it and see what happens. Right. This was my path to
Interesting.
But homebrew is great, and so now I got it, because what I did, there is a builder file which is not executable. So I modified the file a bit and then run the builder, and I got the menu exactly what it described. Right. So there was create Rife 2, create lib, I remember, create app. There was the entire menu. And then I stopped. Okay, we have to talk whether it is used as it was intended to. What I was also pleasantly surprised, that you actually supporting the Maven cargo style. So you can download Maven repositories from the repository central. Which I didn't expect. I think, okay, maybe you're building your own thing, no dependency, but this is actually great. So it means this is absolutely compatible with Maven dependencies.
It completely is. And you can even publish to a Maven repo. So build itself and Rife itself is actually published using build, going through the whole Maven flow. It signs the jars. It does the whole PGP stuff. It creates all the artifacts of the versioning, and you can publish with it.
Which is really hard. What I did, I had to do this with Maven, and it was not simple. So I would say this was crazy. So I did it for several libraries. I did it in the past, and it is not easy.
It's pretty hardcore to figure that one out. But yeah, build supports it too. Try to make it as easy as possible. And now, this is the one thing that I like about using build myself is it's just like with your Java tool. If you're writing your build script and you don't know what to do, you just use your IDE. And you have the Java doc that pops up, you have the method completions, and everything is right there. So like your build scripts document themselves. It's comfortable.
Is it then, I think maybe more inviting for contribution, right? Because you're using the build anyway. So if you're using the methods and something is missing, it's easier to extend build, right?
It is really easy, and you can actually. The basic way of extending it is just putting more other things in your class path, because it's just Java, and you can instantiate any class you want and add more behavior to your build script itself. And the way that exposes itself to your command line, there's a very simple API that just says, hey, this is now a command that I want to use from the command line. This method has to be exposed to the outside world, but whatever is inside that method could be any Java code. There's just no restrictions on it. There's essentially no API.
You're using reflection a lot in the build?
No, there's no reflection.
So what it means is it could be also compiled with GraalVM.
It actually compiles with GraalVM, and Rife 2 also compiles with GraalVM.
It's incredible. So one question, because you didn't use Java for years, right?
Yes.
How long? 10 years or something?
Probably 9. Yeah.
How it is possible that you are so on top of the new stuff right now? I mean, you spent, I don't know, day and night learning, because you know about GraalVM, you know about JBank, which is pretty new. It's just like, or maybe it is easier if you skipped, all the baggage and legacy and just say, okay, now it's a fresh start, and take a look what's.
I think it's the latter. But also I've kept in touch with a lot of people in the Java community are good friends of mine.
Oh, okay.
That I know from conferences from before. We still follow each other on Twitter. We still send messages or in various social media or forums or groups. And even though I'm not actively now I am again, but I had not been actively coding with Java, I did see the projects of my friends appear and hey, I'm the JBang and oh, this is really cool, JReleaser, these things, I see them appear, and I saw Kotlin appear, and I saw it's all of this stuff. It's okay, this is cool. I see where this is going. And then I got really excited and I started paying attention again when there was this new release cycle for Java versions, because we sort of got stuck with Java for a long time where it felt like there was no momentum, nothing was happening. And then having this more aggressive release cycle where every year we go to a new version and there's experimental features, and it felt so exciting to me. It's okay, well, now Java is going where I always hoped it would go because it's so powerful. It just sort of got stuck in this enterprise prison where it's enterprise, so you can't change anything, and let's forbid we do anything that is not the same, right? I'm so happy that the whole community has stepped out of that and is embracing using all the strengths of Java, because it's so incredible. And it's just very steadily march onwards. We're doing cool stuff, let's do even more cool stuff. Yeah, I'm about it.
Yeah, but the enterprise cycle, I think it was really important, because this is why Java became so commercially popular, right? And, and successful. Yeah. Because all the banks or the insurance companies use Java because it was so slow for adoption and so backward compatible. I would say with Java were faster from the beginning, it will be never as popular in the enterprise. And
I agree.
All the large conferences were sponsored by the large companies. So I would say this is this was I think important in the beginning. But
totally agree.
But then it is good that it changed right now, because now the Oracle is on fire, and what they are doing is incredible. Maybe it will interest you. You heard about Tornado VM?
Yeah.
Wow. And Project Babylon as well, maybe. So what this means is what they are researching right now is that you can run your Java program annotated, and it will run on GPUs, for instance.
Yep.
And this is the next interesting, step, because then we get a native Java GPU integration.
I'm so excited about that. I've been, it's sort of a tangent, but it's similar. For the iOS synthesizers that I've been working on, we had very high requirements in terms of graphical performance. In one of the apps we built is a virtual modular synthesizer that is giant, but we wanted to be able to very quickly, in high fidelity, scale up and down all the way out and all the way in, with it feeling completely seamless, no lag, and without any interruption in the audio signal, because we're generating audio at the same time, right? So you can't use CPU. As soon as you start using CPU for these very intensive graphical operations, you step onto the audio CPU that's being used, and you have a higher likelihood of there being an interruption there, and that is really not what you want. So what we started looking at then, and what we've used as the foundation for almost all of our apps, is we completely adopted Apple's Metal GPU pipeline, where they have this very structured approach to scheduling work on pipelines and being able to have this handover that is completely lockless but completely reliable, getting data and buffers into a GPU and then perform operations on there. And the next step that I've been wanting to look at, and we prototyped it but never got further than that, is to actually run the audio code in the GPU as workers. There was still a little bit too much latency for that when we looked into it, but I know one company is doing that now for audio, so it must have become viable. And I'm really excited to start looking into that, because the GPUs are more almost more powerful than the CPUs nowadays. So
Yes. Yeah, and also perfect storm. So in Java, there is a project Panama. You're also aware of it, right? So
I just heard the name. I don't know what it does.
What it does is it replaces. This is interesting for you. Is the GNI? Or replaces. This is the GNI into Java, more or less. So there's a really nice API to talk to a native code.
Okay.
And also the vector API is for the GPUs. And
Nice.
yeah, this is now the perfect storm, I would say.
Yeah.
One question as well, because you mentioned Kotlin. So for me, I have a Java 21, and I'm more than happy. And I see less and less reasons to use languages like Kotlin, Scala, and Groovy, and whatever. What's your take on it?
I totally agree with you.
Okay. Again, so you are boring, conversation, but usually there's lots of fights. But
I'm sorry. Yeah, like I already liked Java before. Like even without all the improvements that have happened, like in the last 10 years. I already liked it before. I was already hesitant to use Groovy back then, or the other scripting languages. I was hesitant, and I never really got into it because it felt risky. And I was more concerned about like the maintainability and stability of my code, and making sure that things would still compile 10 years down the line. So that's why I never jumped on like full bore onto another GVM language. Kotlin looked really interesting when Java was not advancing it as much. But now, today, I mean, the friction points are so little and the gains are so marginal that I have a hard time justifying actually making a switch.
Yeah.
But you should talk to Eric Thauvin about it, because he is a huge Kotlin fan, and he's been using Kotlin for many years up until he started working with me on builds, and then he started using Java again. So he's got a really good perspective, I think, because he didn't really want to use Java anymore before. So that would be a good conversation point when you talk to him.
Yeah, I had already a conversation with Anton from actually JetBrains. He's
good
Kotlin evangelist, and we had a really deep discussion. And there is one killer feature of Kotlin, but interestingly, no one mentioned it so far. There's the native capabilities of Kotlin, the Kotlin multi-platform, I think is the proper name, where you can because what I think is boring if you run on JVM another language, right? Because I'm saying, okay, why on JVM? But Kotlin is different. What they did, they have an alternative stack without JVM, and you can cross-compile Kotlin almost to different platforms. Okay, this is interesting, right? So you can run the same code on Android, iOS, and maybe in web. But I never saw it in the wild in the projects. But I think, okay, this is what I see. It could be interesting idea. So if you already have skills in Kotlin, you can write iOS apps. So, for instance.
So, little tidbit. Eric has been doing a lot of work in the last couple of months to actually allow builds to be used for Kotlin multi-platform. So we're now able to compile and completely build with dependencies Kotlin multi-platform projects with build as a build tool.
Wow. Okay, not bad. So I would say what has really surprised me, the complete different take, because Gradle and Maven are somehow similar, but build is different, right? This is completely different, and the idea is this inverted Maven almost, right? You could, because it's not like you're running on top of Maven. The build could become, your app. So it is like inversion of control almost. And was my observation that that if you have a pattern and you just do exactly opposite, you get another pattern which is also working and working well with different constraints. But but this is also the observation. So what I also like is the design of the entire thing. So I think you did it, the design of the builder page and Rife too.
Yes, yeah,
it's incredible. So I mean, you had a normal job at Moog, and
I still have,
and
we're releasing a new project on Friday.
You created two frameworks, right, in your leisure.
Yeah.
I still don't know.
We use it internally also. Like like my main driving force for this was And it's friction. Like, I knew I could develop an e-commerce platform for Moog's products if I would be using Java, because I know how productive Java is. My problem was no one else on my team knew Java. So I knew that Rife had a particular structure that I could very easily explain to them, and that would make them productive and write code that they could all work on together without having to learn the whole GEE stack and all the complexity of that. So that's why I went down that route, because it's like, okay, if I do this and I document the few pieces that they need to know, I'm very confident that my team can achieve success with this. And then while we were on this path, I saw how messy Gradle was. We tried it out, and I saw how everyone was struggling with it. And it's like, there must be a better way. And it's basically, the way I always look at this is, it takes a lot of effort at one particular time. It's like, okay, am I really going to create a build tool? Like, am I going to be that crazy to start this off? But the time invested to do it in a way that, to me, feels way more pragmatic and way more productive, I've more than made up for it. Like, because my whole team understands it, they're completely self-sufficient. They don't have to deal with any of the idiosyncrasies of JE or Gradle. Like, they just treat it, hey, I'm just coding a new thing in an awesome IDE, and look at how productive I am. And they're just having a good time.
They had no experience with Java, your colleagues?
No, nothing.
What they did before? So were they programmers or?
Oh yeah. They're like C++, Swift, Objective-C, Python.
What is their reaction to Java?
They loved it. They were like, oh my God, like, I had no idea how comfortable this was. And having IntelliJ, they'd never actually used an IDE as powerful as IntelliJ.
So what it means is, actually, with your stack, Build and Rife and IntelliJ, it could be the next big thing. This is the revival of Java, maybe, because this is the interesting part. What is the reaction of a new developer, and what is the onboarding experience, and time to Hello World. There's also and if this is working, then so what they had to do, they had to install Java 21 first, then put Builder in a class path. And that's basically was, right?
It's if you use Homebrew, then you don't even have to do that. You just install it through Homebrew.
Yeah, right? This is what I also do. I would try it with Homebrew. Okay, this is incredible. And what was they complain? So there was something what they didn't like at Java. Oh, it's always something. Is there something common thing where they say, okay, this is just crazy in Java, or something they didn't like, or?
Let me think about that. There must have been something.
I
think the main, when I remember a big friction point was, but it was actually not Java related, is more like HTTP related. They were not used to thinking in RESTful HTTP designs. They were not used to thinking about structuring your URLs that they make sense in a RESTful approach. And I remember that was something that I had to sort of flip their brain around. Also, even though I'm a really big fan of the template engine that I designed, there was 2 people on the team that really struggled with it, because it's kind of a mind flip. Because some of them had used PHP before, and they were like, oh, this template engine is like PHP, but it's, again, the complete opposite of it. So they were really struggling with understanding, with their preconceived notions of templates having a control flow, and basically the content being mixed in between the control flow, which is what PHP and JSP is like. They were trying to approach it that way. And for that, I actually had to sit down with them and walk them through it. But then I wrote the documentation, adapted the documentation afterwards. So it taught me a lot.
Yeah, always. So this is what I also appreciate, to explain something to someone. So recently I tried to explain, static methods to someone, and not easy. I tried, so it's very easy, and then it's okay. And I got the question, when I should use static method and an instance method. And I said, this is a really good question. Try to explain with with of course state and classes and objects. But if you don't know the concepts, you cannot explain. You use instance method if you need the state and classes, and the next question is when you need the state. This is this is interesting. So, but coming back to the templates. So imagine hello world. So I have a string hello world, and I would like to use your template. So what is exactly to do?
Let's imagine you're building an HTML page, right? Okay,
of course.
And hello world is like an H1 tag inside an HTML.
But with a hole, right? So I would like to have a hole.
So what you would have is the HTML page with the H1 tags, and in between those H1 tags, you would put in a Rife template tag, and that will give it an identifier that becomes the whole. Now, one of the design approaches there is there's two versions of the tags. There's a short form and there's an invisible form. The invisible form actually uses the comments of the actual language that you are annotating. So in the case of HTML now, it will be an HTML comment, and the tag will be invisible when you preview it in a browser. And you can give each whole default content. So the way I would do what you just asked for, I would basically have like that Rife, it would be a value tag, because this is where you put a value in it. You give it the ID hello, and then in between the start and the end of the tag, you would write, I don't know, placeholder or whatever, and then you open it up in your browser and you just see an H1 with placeholder. It's like, oh, this looks nice. Like you can just preview it with any existing tool, use any like HTML editor, CSS editor, whatever editor, and whenever it goes through the Rife template engine, it will compile it to bytecode, save it as a class file, and then plug in those holes where it knows that it has to replace things that you have values for.
And if you compile it to bytecode, is the entire template a string and this is like a placeholder, or you're understanding the tags?
I understand the tags and the structure.
So it's more like XML parser.
It's more like an XML parser, but with different scopes.
Okay. Yep. And how to put, the hello world to the engine? So there's like a context. You say context put, and you add.
Yeah, context print.
Oh, okay. Yeah. And if you have a loop, let's say I would like to have a table.
Then you have the value where you want the table to accumulate. Basically, what you would do is you would style the template with the table in one row, and the row would become a piece of reusable content, again, with holes in there. And from within Java, you would say, get me the reusable content that's a row and put it into where I want to accumulate rows. And you can just keep adding to that. And in Java, you can use any logic you want. Like it could be a loop, or it could be a stream, or it could be whatever that is driving that bidirectional communication. Like it gets the content from the template and it plugs it back into the holes. So now your logic is 100% in Java. You can abstract it out in classes. You can have it being driven by some other logic that you want to be able to accumulate things. So you get rid of that problem where you have a control loop inside your template, and now you need to figure out what are the conditions. Like, how do I get all these different states that I would need to have? You don't have to get that in your template. Like, this could all stay in your business logic or your layout logic.
So what it means that the template engine is like a mediator between the actual template and Java, right? So the template is driving. So the template says, okay, I need some content, and it calls Java, right? It's not the other way.
Java calls the template. The template doesn't do anything. Look at it like a puzzle. It's just pieces of stuff, and Java is picking up the pieces and saying, okay, you're going there, and you're going there, and you're going there.
So is this about the whole does request the content, or the content has to be put to the context?
The content has to be put into the whole.
Okay, then this is very similar to string templates, right?
Yeah.
Or formatted in string. So the string formatted is like very basic version of your template, right? The formatted method.
Yeah. It's similar.
So what it means, list, li, or OL, ordered list, and LIs, it means there's a specific tag, so it knows the repetition. So there's a reusable part is the LI, right? And the
no, you would be writing what is called a block tag around the LI part, because that is the block that you want to repeat. It is agnostic of language. So here's a cool part. Imagine you have a web page that you want to display a purchase confirmation to someone that has a particular logic to it. Like it is, hey, this is your customer name. These are the items you've purchased, right? Your structure is usually very similar to what you display, for instance, on a web page or in an email that you send out, right? The structure is the same, but your formatting or content is different. So with Rife's template engine, you write the exact same piece of logic. Like you just give it another template that has the same IDs for the placeholders and the values and the pieces of content that we reuse. But whatever is around it, whatever is inside the reusable pieces of logic or outside that forms your template, that can be any type of string. So I'm actually using it a lot to do JSON like web service calls, because you have these usually when you like interact with any type of API, like REST JSON API, you have like a blueprint. Like this is what your call looks like to talk to us, right? I just put that into a template, and then wherever the changeable pieces of information are, I put like a value ID.
Yes.
And I just send that to the servers. Like no need to do like object serialization or build an object graph.
It's like a text block.
Right?
Like a text,
it's like a text block.
Text block was formatted. But what I still didn't understood, you said a block tag. So the block tag has to listen or not listen, accept lists.
No, a block tag basically just says, I'm a piece of content that you can get out of here. Yeah. That's all it needs to do. And then a value tag is, I'm a hole in which you can stuff stuff. And if you want to build out a list, then you put several times the block inside the hole and you just create your list items.
So, exactly. And the several times, how you do it without control logic in the template, because
you do it in Java. You do in Java. You basically say, get the block and get the block content and put it in this value, or add it to this value, right?
So it means you have so you have a value slot, and you can put into value slot multiple
blocks.
Okay. Yep. So I know I got you.
Yep.
So what I assumed is that there is a specific value, value slot, and like block slot, and the block slot accepts lists. And there is some repetition logic which creates the other ones. Okay.
No, yeah. So there's really absolutely no logic in the templates.
Okay. So you have only value slots, right? Value holes.
Value holes, yes, and block content that you can get out of it.
Out of it. Why you would like to get something out of it?
Because that is how you accumulate that list. You can say, hey, this is what the block looks like for a list item. And in Java, you say that block has to go into that value hole and add another one to it and add another one to it, right?
This only works because you understand the structure. So what you get in Java is not like a string. I get in Java the structure of the template, right?
You get identifiers for each piece of the structure that you can work with. Yeah.
Okay.
And that's why it's a different approach, and it takes a little bit of getting used to, and that's I call it a bidirectional template engine, because usually template engines are only one directional. Like you put stuff in there and then things execute, right?
Yeah.
While here it goes in both directions, so that your logic can really do everything you want in Java, and your text and in your template is just content, just pieces of stuff. And it doesn't matter if it understands the logic or not.
I have to take another look at the bidirectional nature of that thing, because I can imagine how string template is working formatted, so that everything is fine. There's the holes is like a holes what we already have, and you have the IDs, and you can refer in Java to the IDs.
Right.
And what it means, I still don't know, the list. I have to take a look because the list, if the ID is given, so there's only one slot. If I will populate it, I would just override it. So there has to be a way.
You can append to it. You can either like replace the content or add to existing content to accumulate.
Okay, so you have replace and add, right? So
yes,
okay.
Essentially, yeah.
Okay, so this is okay. So what it means for me is I can pull the reusable part of the template to Java and then decide whether I would like to delete it, override it, or append it, right?
Yep.
Okay, then now I got you. So this is like your templates are more or less alive. You can create. It's almost like a DOM.
Yes. Yep. It's pretty similar.
This is like a DOM. So now I think I got the thing. So you have a DOM, right? So you can define the entire template in a DOM in a browser in HTML. So you did this in HTML. Then the DOM structure is created for you. Then you're now in JavaScript. So you can decide. You can, for instance, say query selector. I'm interested in the ordered list, and you get it back. Then you can remove things, you can add things, and this is the bidirectional thing. So
exactly.
But what you could even do then, I don't know whether it's possible with Rife 2, you could create the entire template in Java.
You can, yeah, if you want to.
So there will be no string templates. You could create like a DOM, the entire with Java, and then okay. Yeah. So what you created is actually parts of JSF.
In a way.
Yeah, Ice Faces. You remember that?
I do. Yeah.
So what they did, they started with a browser, and they were capable of to understand the entire HTML and DOM structure, and they were very fast. And then JSF happened. They said, okay, cool. So we moved the DOM part, to the server and to the browser. And if they some a transformation in the browser, it gets synced with the backend, and this was the entire trick.
Yep.
And so I think but the building the template engine was not easy, right? So you have to understand the structure. You should be able to. I mean, it
was a lot of work. It's gone through quite a few revisions, and for Rife 2, I actually rewrote it because I wanted to use Antler for the parsing. I had like a custom parser before, and I wanted to actually do it with Antler and write the actual like parser structure out, be able to properly get error reporting out of it. So yeah, that was actually probably one of the biggest pieces of work of doing Rife 2.
So what you created is basically a DOM tree where you can, and
except that I guess it's a DOM tree with a lot of like free text that can be anywhere, right? Like very free form, and then compiled. That's the other part. Like compiled. If you use the text files as the templates. It compiled to bytecode, and you can ship it with your app, and it runs extremely fast because it's just basically
sure.
Java bytecode. Yeah.
Are you aware of custom elements, web components, and templates?
I've heard of web components.
Yeah, there's web components, and they have the notion of slots, so you can predefine, and you can refer to the slots and replace them. Also very similar. So it is actually really interesting technology you created, right? So it is really like it. So I think we covered a lot, and in one point of time, if there's Rife 3 on the horizon, we have to talk again because you have a fresh perspective on Java. Because if you restart right now and you do things, because for me, I was okay. I'm somehow happy with Maven. I will never create my own build tool, but it's really to see someone like you. It's like I have the real need, and for me, it is really interesting that you are using your framework for non-Java programmers, and they like it. So this is the best thing can happen, right?
I think so too. So thank you for recognizing that.
Yeah. Thank you a lot. Where people can find you, your company, and Moog synthesizer if they like to buy one,
moogmusic.com. You can also, like my own company is called Uwyn. It's UWYN.com, where it's got links to all my various weird projects and ideas, Rife and Build just being a couple of them.
And on GitHub, if you search for Rife 2 and BLD, you will find both. And perfect. Thank you a lot. It was really
thanks so much, Adam.
Super interesting.
Awesome. I'm glad. Well, thank you for having me on twice in a row.